What does it mean when two triangles are similar? How do I find out the lengths of the sides of one triangle if the length of the sides of the other triangle are given? Do you answer that?
Yes, I can. So this is going to be a little bit of some geometry, but if you cut to my screen, I'm going to draw you some pictures to help you get this concept a little bit better. And I'm going to do my best to draw truly similar triangles. And okay, we're going to try, I think. All right, so similar, this word similar, in of course English means they're close to being the same. But in math, it has a very specific definition. In geometry specifically, what it means is, it means that the side lengths and the angles, well, okay, your angles are going to be the same measurement, and the side lengths are going to be proportional. So essentially what that means, and I'm going to just make up some side lengths to show an example. Let's say that this one was 3, and then this base here was 4 units. What you would have is what's called corresponding sides. So this side that I'm highlighting in yellow, if these two triangles are similar, then the side that I'm highlighting in yellow here would be corresponding to it. And then again, this bottom one would be corresponding to the bottom as well. So if they're truly similar, then what it means is we can set up a proportion. If I don't know what this bottom side length is, I can set up a proportion using my, and you just have to make sure that the yellow stays on the same either numerator or denominator that the pink does. So I'm setting this up here so you can see it. All right. So if I know that the side length of this left-hand triangle is 3, and then the other one is 4, I know that 6 corresponds with this 3, and then the x is going to correspond with the 4. So see how I color-coded that to make sure that the corresponding sides stay either the same if they're numerator, numerator, denominator, denominator. Because they're similar, that means they're proportional. So the way that you can solve it is there are a bunch of ways to solve proportions, but I'm using one of them, which is equivalent fractions. Meaning if I want to get from that 3 to the 2, or sorry, the 3 to the 6, I have to take it 3 times 2 equals 6. So whatever you do to the top, you have to do to the bottom. And it's really not mathematically technically correct, but it kind of rings, and you can just remember that what you do to the top, you got to do to the bottom. So if I'm multiplying my numerator by 2, then I'm also going to multiply the denominator by 2. So that means that x is going to equal 8. And this side is going to equal 8. So you can kind of see the similarities between these two triangles. They are not exactly equal, so they're not equal to each other, but they are the same shape, and then the side lengths are proportional. There'd be a lot of similar triangles to this 3, 4 triangle. You could do a triangle that would be 9 and 12. Anything that really is proportional. So really that's what similar means, is that the side lengths and corresponding side lengths are proportional to each other. And I just gave a little bit of an example to help out with that idea a little bit. But without, I guess, a specific question, it's hard to answer more than just what it is. So hopefully that helps.